When we're factoring, we'll always want to do what we consider factoring something completely. What that's kind of code word for is maybe there's sometimes when more than one time, we can factor more than one time in each problem. So far, what we've encountered, we factored it once, we're done with it. Maybe that's not always the case. For example, if I have 4x cubed plus 28x squared plus 24x, and I want to factor that completely. Here's what happens on this. First of all, I'm not told how to factor it. That's up to me as well. When you come across a factoring, that's usually the way it works out. It's not going to tell you how to factor it, so you have to decide for yourself how about do we go about factoring this one. Well, first of all, when we're factoring, don't think I've written it down yet, but we always first want to look for a GCF. Kind of mentioned it as we've gone along here, but let me stress it right now, is that always you want to look for that GCF. And I'm talking about of all terms. Is there a GCF? Sometimes there isn't, but in this case, I do believe there is, right? There is a GCF, so that's where we're going to start. GCF, because I've got 4, 28, and 24, there's a common factor of 4. And then x cubed, there's a common factor of x. So I do have a GCF here of 4x. So I'm going to take that one out of each term. So that's, divide that by 4x, you got x squared. 4x off of that, 7x. And then 4x off of that is 6. So yeah, when we were doing GCF factoring, that was it. That's all we had to do. However, since now I need to think factor completely, here's the deal. Yeah, once you get the first factoring done, let's say, make sure nothing else factors. That, in other words, the factors themselves, make sure those don't factor or factor them if they do. Yeah, it turns out this trinomial here factors itself, right? X cubed plus 7x plus 6, that's a factorable trinomial. Now, 4x does not change up, but can I factor this trinomial back to our two binomials here? And it is the nice easy kind. It's x squared here. So that tells me it's x and x. And then what about 6 on the end with 7 in the middle? 6 and 1, isn't it? I can factor 6 as 6 and 1. 6 plus 1 gives me 7. Yeah. So this trinomial does factor, once again, to that. And so here is our final complete answer, 4x times x plus 6 times x plus 1. Okay? All right. Try this one then. 18y to the 4th minus 32y to the 2nd. Again, I want to factor it as much as I can, completely factor it. And so I'll first always look for that GCF, and there is such here. GCF, isn't there? 18 and 32, 2 goes into them. I believe that's highest, isn't it? 2 and y squared. 2y squared GCF. So let's factor off of 2y squared. So if I take my 2y squared there out, at that. Not much better there, but okay. All right. What does that leave me? 9 y squared minus 16. Try that again. 2y squared. Get this pen to work in here. 2y squared. It's 9y squared minus 16. I think that's a new pen, and it's not working hardly at all. All right. Now, we can't stop there because what else can we do? Well, then we've got to check, see if these factors factor themselves, and what about this 9y squared factors again, doesn't it? How so? It's a difference of squares, isn't it? Yeah, for binomials, we look for squares and cubes. This one happens to be squares. That's a square. 3 squared, that's 4 squared. So yeah, I'm going to bring down my 2y squared. There we go. It factors as a difference of squares, 2 binomials, 9y squared, so it'd be 3y, 3y. 16 is 4 and 4, but one's a minus, one's a plus. 3y minus 4, 3y plus 4? Okay. So yeah, that's that's the thing we're talking about now, is factoring them as much as we can. All right. How about this one? Minus 10y to the 4th plus 45y cubed minus 50y to the 2nd. All right. Nice little factoring one. I mentioned in previous lecture there that if you have a minus in front, the largest leading power term is a minus, you might want to do in your GCF what? Factor out a negative as well. Yeah, if that's minus, then my recommendation, the first term's minus, then make the GCF a minus to go along with the what? 5y squared. There we go, yeah. That leading term being minus, let's do a minus 5y squared GCF. And what that does is that, of course, changes signs. Take off a minus 5y squared, that leaves me a 2y squared, because a minus divided by minus is a positive. Positive divided by minus is minus 9y. And then a minus, again, divided by minus is a positive 10. Positive 10. Don't have to do the minus, but it does help in the long run. Because now we need to think about this. Does this one factor 2y squared minus 9y plus 10? And yes, of course it does. That's why I'm doing it right now here. Okay, so that's, now this is a 2y squared, so I've got to do a little trial and error here. It's 2y and y for 2y squared. I've got 10, that's 2 and 5, could be, or 10 and 1, which neither one of those add together to be 9, but again, because this is 2y squared, that doesn't matter. However, what does matter is this is minus in between, in the middle, so what is that telling me? Both of them are going to be minus, yes. I'm going to do a negative 2 and a negative 5, or a negative 10 and a negative 1. Let's just try a negative 2 and a negative 5. And of course, I know whether or not that works based on these two things. Multiply the two out parts and the two inside parts. Well, no, that isn't it, because that's a minus 12y. I need to be minus 9y. So let me flip-flop those around. I believe this will be it, right? 5 there. You do 2y minus 5 and y minus 2, because that'll be a minus 4y, and that'll be a minus 5y. It's a minus 9y now. It's okay? All right. Now, let me mention another ingredient here that might come along our way. And that is this. Everybody got this one?